just think, you have been given, just think, you have been given a gift. You have been given a memory of a lifetime.
No way.
Yes, this is like, you will reflect on this in 10 years. Like,
No, I watched
incredible.
I think about that and then the drama performance I was forced to do.
Oh, man.
In a chapel.
So good. Thank you for sharing.
I'll find the video for you.
Thank you for sharing.
Actually, like,
Oh, thank you.
really should have listened to Hadley.
yeah, we should have listened to Hadley. She was like, it's gonna be so embarrassing. I was like, no, it's not. Yeah,
I was like, it's not great.
I'm trying to like prove this with like blocking it. And then we actually hit one.
And you're like, oh, okay.
Okay, hey, when you multiply radicals.
Anyway.
Anyways, you have to have the same index. Alright, so a square root multiplied by a square root, thumbs up. A square root times a cube root, you can't combine them, okay? So you have to have the same index when you're multiplying radicals like this. Now, square root of 2 times square root of 7. We actually talked about this a little bit yesterday. It would just be 2 times 7 square root of 14, and you would be done. We'll just call that number 1, because we're kind of doing some problems here. Now, if you have the square root of 2 times the square root of 6, again, the challenge is for some of you, you're just going to go home and plug it in your calculator. It's going to give you an answer. You're going to move on. Don't do that because you will then not know how to do it for the test when you don't have a calculator. Meaning, you on the test might say square root of 12, but your calculator actually gives you 2 root 3. And you're like, so the calculator gives you 2 root 3, you box it, you're done. On the test, though, because you didn't know what you were doing, you put square root of 12, and now you're stuck, which is not simplified. Well, why isn't square root of 12 correct? Well, under square root of 12, don't forget what we were talking about yesterday, it's 4 times 3 to give you 12, right? And the square root of 4, what's the square root of 4? 2, so that has to come out. So, again, I'm not saying you can't use a calculator at home, that's going to be your choice, but you won't be using one on the test, you have to know how to simplify to get to there. The other thing sometimes that the book shows or whatever is on this, it's a square root of 2 times, what is 6 made up of? Well, 6 is made up of 2 times 3, right? And so you can think of the square root of 2 times the square root of 2. What's the square root of 2 times the square root of 2? 2. Or square root of 4, right? Which is 2. If I asked you, what's the square root of 17 times the square root of 17? The square root of 17 times the square root of 17 is 17.
Yeah, because then you like
Well, we need more than just sure. It's the same thing as 17 squared. The square root of 17 squared is just 17. You don't have to even know what 17 squared is. What is 17 squared though? 289. Okay, so okay, so let's try it again. Square root of 101 times the square root of 101. What's the square root of 101 times the square root of 101? 101. Okay, so yeah, so however we get there, you know, we need to end up with the 2 times the square root of 3. Now let's do a couple other types of examples here, and we'll say 3. What if we end up having something maybe slightly more intensified? The square root of 33 times the square root of 55. What they're not actually looking for you to do is 33 times 55 longhand, and multiply it together, and then try to, they're actually not looking for you to do that. What they're looking for you to do is recognize, like I showed over here on the bottom, a little sloppy here, but 2 times 6 is 12, 12 reducing to this is not too difficult. 33 times 55 is going to take a little bit more work, and that's not what they're looking for you to do. They're not looking for you to multiply these two together right away. What they're looking for you to do is recognize 33 is, what are the factors of 33? 33 is made up of what? 3 and 11, right? And 55 is made up of what?
5 and 11.
5 and 11. So what they're looking for you to recognize is, in this case, the square root of 11 times the square root of 11. What's the square root of 11 times the square root of 11? 11. So that's what they're looking for you to have, is just the square root of 11. And then on the inside, what are you left with on the inside? 3 times 5 is 15. And so that's what they're looking for you to do on that one, right? Again, if you go 33 times 55, you'll end up with a big number, and you'd have to figure out the perfect square that went into that to reduce it to this, which would be 121, because 11 times 11 is 121. So you'll have to be looking for trying to factor these so that you don't have huge numbers. Let's try another one here. Why don't you try this one real quick? 54 times 48. Again, they are not looking for you to go 54 times 48, come up with a big number, and then simplify it out from there. They're looking for you to recognize that this is probably going to have some sort of multiple involved that will allow you to do what we did up here. Now this one is pretty easy because there's only 3 and 11, 5 and 11. 54 could be 27 and 2, right? It could be 3 and something. So go ahead, figure out how to reduce these inside a little bit first, and then combine, and then go from there. So, and then check. You can check with your support team around you. You can do too, and you could try. You can also work with individual perfect squares on like the 54, right? There's multiple ways to do it. Okay, good work. All right, so on the 54, you could split that into
6 times 7.
6 times 9, or 9 times 6, good. And then what we like about that is the square root of 9 is just going to be 3, so we can simplify there. 48 could be
6 times 8, or
8
8 times 6.
times 6. The issue with 8 times 6 is, and that is actually not wrong, but we don't have a perfect square in it. But we could, since we said it, let's just go with it. 6 times 8, right? 6 times 8 is 48. So, because there's multiple ways you could keep simplifying this. So if we work with this one, what's the square root of 9? That immediately comes out. It goes away from the square root, right? The square root of 9 is 3. Now the square root of 6 by itself, you would have to leave it as, I'm not going to write it here because we're going to do something, but you couldn't get rid of it yet. But we could recognize, oh nice, the square root of 6 times the square root of 6. What's the square root of 6 times the square root of 6? 6. So this turns into 6. Now remember, it's times. This is all times, so 3 times 6. Now you're left with the square root of 8, which you might do initially. We'll change that. Because then you'd have 18 square root of 8. Is 8 reduced all the way? No, because what perfect square goes into 8? 4. So if you need to, you could write this out as 4 times 2, and then the square root of 4 is 2, so it's 18 times 2 times the square root of 2, so 36 root 2, like that. Okay? So there's other ways that you could do that. You wouldn't have to do it all out that way. Somebody have a different way they did it?
I did it wrong. Yeah.
I did it wrong?
Yeah.
Nice.
Works
Nice.
for you.
I just did partial way.
I did like partial.
Just partial way.
Okay, does this make sense there, at least how we got there? 54, you could have broken into, you could have recognized 54 is 9 times, you could have said 6 is 3 times 2, and then 48 you could have recognized is, I don't know, what is 16 times 3, right? And then you could have recognized square root of 9 is 3, square root of 3 times square root of 3 is 3, square root of 16 is 4, and then you're just left with the square root of 2. You could have done that. 9 times 4 is a 36. So a couple different ways to get there on that. Okay, let's throw in here what happens when we have a variable expression. Let's just do one more here. Cube root of 4x to the 5th, y to the 7th. Now, if it's a cube root, what does it have to be multiplied together by? So, or in order to combine them,
The same.
index, right? So cube root has to be a cube root. Now, in this case, remember, cube roots, you're not looking for perfect squares. So you're not looking for the, you know, this quick side note, the cube root of 6 times the cube root of 6 is not 6. Because cube root represents what times what times what. So 3 things, right? So the cube root of 6 times 6, that's the cube root of 6 squared, that would not be 6. The cube root of 6 squared does not cancel out to be 6. Now, if this was the cube root of 6 times the cube root of 6 times the cube root of 6, how many 6's do I have there? 3. What's the cube root of 6 cubed? 6. So that would work. So just be careful in that. All right, so here I have the cube root. If I go ahead and just combine them, what is the cube root of, what's 4 times 2 give me? 8, right? And then x to the, if you ended up combining 11th, y to the 8th. Remember, when you multiply the same bases, what do you do with the exponents? You don't multiply the exponents. What do you do with the exponents? You add them. 5 and 6 is 11, 7 and 1 is 8. Okay, now the issue is the cube root of stuff, right? So the cube root, if you think about what's the cube root of 8, hopefully we would get that one. The cube root of 8 is 2. So that comes out as 2. Now the challenge here is to think through the x to the 11th. Because remember, perfect cubes are what times what gives you x to the 11th. Well, no 3 things in and of itself added together give you 11, right? Like 4 plus 4 plus 4 is 12, 3 plus 3 plus 3 is 9, so that doesn't work. However, you could recognize that this is the same thing as, maybe you could recognize this, x cubed times x cubed times x cubed, right? Times, how many do I have? 3 and 3 is 9 times x what? Squared. And then x to the 8th would be, y to the 8th would be y squared times y squared times y squared, and actually times y one more squared. Sorry, there's a lot of y squared going on. Now, the challenge here is recognize that this, since there's 3 of them the exact same, the cube root of x to the 9th, this is the cube root still, sorry, is going to be x cubed. One way you can look at that, sorry, I got to do this over here. I just wanted to break it out that there's 3 of the exact same thing here. You can say 9 divided by 3 evenly, right? Would be leave you with x cubed. Okay. Then you'd recognize this, then you'd have, you're left with x squared under there. Then you recognize a multiple of 3 there, right? Y squared, y squared, y squared. So the cube root of y squared multiplied by itself 3 times is the same thing as saying the cube root of y to the 6, meaning 3 goes into 6 evenly. How many times? Y squared. And then you would say you're left with, what are we left with? X squared and y squared. Those do not come out because this is the cube root of x squared. It's the cube root of y squared. Now, if this was the cube root of x cubed, would it simplify out? Yes. Cube root of y cubed, it would simplify out. So with perfect cubes, you're looking for 3 going into something, right? So let's try just briefly over here. Maybe we should have started a little bit easier. But if I have z to the 5th, we know that 3 doesn't go into 5 evenly, but is there something in there that we could reduce it to that 3 goes into? Sure. If you said instead of z to the 5th, what could you say? Z to the what times z to the what? Well, you could go z to the 1st times z to the 4th, but does 3 go into 1 or 4 evenly? No, so that wouldn't be helpful. But you could reduce it or change it to z to the 3rd times z squared. Whoa. That was awesome. So you could do that. Now, and then that one would simplify out for you. There we go, 10.2. And I'll get these printed, I think, off next week. But 1 through 33, Bob. And then we have 14, 20, 46, and 48. Now, next week, what is due on Monday?
10.1.
10.1, yeah. So Monday 10.1 will be due. Tuesday we'll make 10.2 due. So
I'll text my
10.2.
mom. I'll text my mom to see if she has the video.
Please.
I have it. You have it, like on your phone.
Don't forget to take your snacks and drinks for you
Oh,
people.
yeah,